today is an OpenEVSE, which is an open source EV charger. Because I've now got a plug-in hybrid, I've got a Mitsubishi Outlander PHEV, so I've bought myself one of these so I can charge it and monitor the charging progress as well. And it's got a web interface built in and all sorts of other bells and whistles, as we'll see later on. So this is what I've ordered. I didn't order the cable, I ordered a cable separately from eBay, so we'll take a look at that in a sec. Now what we've got in the box, for the unboxing, is the OpenEVSE unit itself, which in turn contains a whole load of goodies. We've got cable glands, there's an earth terminal bar, there's a contactor, that's the wireless module, there are current transformers, bits of bubble wrap that the current transformers used to be in, there's a push button, nuts and bolts, some cabling, colour coded, the display, the spaces for the display to mount on the back of that, and this is part of the unit. This is the controller itself. This is the OpenEVSE. In fact, it's an OpenEVSE Mark V. So let's bring that up for a closer look. Let me refocus on that. There we go. Bulk of this at the front is a AC to DC converter, basically a power supply in a pot. All that side is all mains rated stuff, all the low voltage stuff is all over here. And there's not really that much to see, it's all based around this Atmel chip here. Can I focus in on that? Let's see if I can focus on that. There we go. So the first thing I need to do isn't to assemble this. I've got to add the first Bugbear on here. I've got to add another hole and another gland, because this is designed to have a cable coming in and a cable coming out. I need to fit an earth rod, and this hasn't got provision for taking an earth rod gland, so I'm going to have to drill the front of this case and modify the back plate so that the gland can fit and the cable can come through. So let's get that out of the way. There we go, gland fitted, and I've cut the bottom of the base plate now so that will fit properly like that. Well, there are instructions online and they say to start from the top, so that's what I'm going to do. Let's pop the bag open. The first thing I need to do is remove this clear protective film from both sides of the plastic window. And get the screws out. This is sealed in half, this bag. So drop bits on the floor. And I'm going to put a 10mm screw through one of these holes, flip it over, put the foam bit on, then the clear window, and then one of these standoffs. And do the same for the other three. And the next thing before we mount the display is mount the button, which is wrapped up in this little bit of bubble wrap. Lots of little bits of bubble wrap in here. And the button is one of these sort of vandal resistant push switches. Like that. And then we're going to mount the display module. So a few things in here. This is the display module and there's a box on the back as well. Obviously got to pull the protective film off, and this goes that way around, so that says 1707, not lol. And that mounts on there. That's the front of the unit, almost done. Next up we're going to turn our attention to this, which has some more of these aluminium spacers, so they go in like that. Then we've got the earth bar, which goes in using these self-tapping machine screws. They're in the set, and it's the two longest screws of the set, and these will go in through here. And then we're going to mount the contactor, which is quite small for a contactor in my opinion, but that's, I'm used to these big three-phase contactors. I want something big and chunky, but this is reasonably chunky, so that can go on there. The screws are a bit tough going, but not as tough as it could be. This is aluminium, so they do bite in. But probably better if I actually had the correct size screwdriver. Probably the next size down would be better. And the next thing to go on is the controller, which goes with the AC side over that side and the DC side next to the earth connection. Just like that. Next up we have some of the wiring to do. This is color coded and it's labelled on here as well. So the first we have these two purple wires, which are the AC test connections, and they go to the top and bottom right power terminals here, so they can monitor the output from the contactor. Like that. We have AC relay connections here, which actually control the relay itself. So one goes on this side and one goes on this side. That leaves us with the AC line connections. One goes to the top, one goes to the bottom, and because these are designed with the American colour scheme in mind, this isn't neutral and live. This is actually going to be for the American market, that will be live 1 and that will be live 2 with 110 or 120 volts either side of the ground connect of the neutral connection. In the UK this one is going to be neutral and this will be live, so the top level, the one closest to that will be neutral, the live will be a bit more safely out of the way. And we've got the 4-pin coil here, which is for the ground fault interrupter or RCD, and that connects to there, and we'll route down here. And we're now ready to mount the whole base unit in here. Now the next thing to be connected is the EV cable. So I'm going to put these to one side a sec and we'll take a closer look at that. And what I did is I ordered a second-hand one on eBay. Sometimes people buy a Type 2 cable to replace a Type 1 cable and they'll sell the old one on eBay. This is 5 meters long, it's rated at 32 amps. To give you an idea of scale for that, they do vary in size. This is the one for the charger that comes with the car, which is a 16 amp charger. So you can see the plugs do vary. They vary between manufacturers as well. That one's obviously ITT, it says on the side. This one is a Yazaki branded one. And to give you an idea of scale, that's a 16 amp yellow top industrial connector, and that's a 32 amp one. diameter, it's about the same because we have a rubber cover here, which I've also bought to go on there. Sometimes they come with them, sometimes you need it separately, and that is a perfect fit on there. Anyway, I need to fit that, so I'm going to open that. And there we go. So that's the lid, and that's the connector. You see obviously the connection's going in, but there's also a micro switch in here. So when you push the button to release the catch, it will inform the car, so the car knows you're stopping charging before you actually pull the lead out. Anyway, I'm in here to put this on, so that will just go, should just go in there ish. There we go, one rubber cover fitted, just like the one that came with the car. Now this needs wiring in, and this goes in through the right hand side cable band. There we go, that's in tight as a drum in that cable line, that's not going anywhere. And the power leads both go through this trip coil, but not the ground and pilot leads. I've pushed that forward with enough slack so that can go in, and these will then go in here. So there we go, that's the pilot contact in. There's another pin there marked PP, which I believe is used on the Type 2 ones. They have an extra connection. This doesn't need it. Display cable plugs in there with a black wire on the left. I'm going to come back to the top now because I've missed a step. And that actually connects around to there. There's a few more bits and pieces still to connect. I've got this data connection here, which has the black on the right, and the black is also on the right on here. You could be careful when looking at the instructions online, because the black and the green look almost identical. You'll go really by the position of the red wire. And I've got some slightly different instructions to go to here, because I've also got this wireless module to connect to. And the thing I don't like about this, the one thing I really would want to change in this design, is that this is expected to be fitted with double-sided tape. It's just meant to sit there. So this is another connection cable which plugs in over here with the two wires closest to the right hand side. And you've got this power module then, which picks up a supply from the relay connections here. Wish that would fit down a little more securely. But then this connects to the Wi-Fi module with ground connection there. Like I said, that is then meant to stick on there, and that's just not right. That's better. I've got the corner screw off. I've got this small plastic washer because there are some connections fairly close by, so I'll just pop that on there, and that mounts there. The panels are following 3 sets of instructions. In addition to fitting the trip coil, because I've got the current measurement coil as well, that goes over one of the wires. 2 go through the trip coil, 1 goes through that. Now it's ready to test. I'm not going to wire it in place yet. I'm going to just use a normal kettle lead and cut the plug off. Obviously the final wires will be a little thicker than this, but you could actually use it with this. This is actually controllable. You can dial the output current right down. One other thing, it did come in the box. I did spot a watch battery and it's gone walkies, so hopefully I won't need that. I think it's just for setting the real-time clock and not storing parameters or anything like that. Anyway, let's try it. You've got the wireless connection with the ground over on the left, and we've got this with the ground over on the right. That should be all the connections made. Pop the lid on and watch it go bang, or not. Not. What's going on? You need to double check the connections on these things because it's very easy to get them the wrong way round. I just had to swap that over. Hopefully it's designed to take them to withstand a backwards connection. So the black one closest to the left. It's very easy if you look at the instructions to get this wrong because the green almost looks black on some displays. Anyway, now everything's plugged in. Let's see if it'll start up, or will it go bang? So yes, it is protected against reverse connection on there. And by default we've got an SSID of OpenEVSE and a password of OpenEVSE, so we can connect into this. And this is its standard display. Set the date and time, the backlight type. All of these instructions are going to be online. This you can adjust. You can see the maximum on this at the moment is 32 amps. I'm going to dial that down. You can see it starts at 6 amps and you can clock it up. I'm going to take it to 24 amps because it's lower than the rating of the breaker. It's set about the SSID broadcast, and you can see if you look on here, there's OpenEVSE 692442 broadcast in there. So I'll be able to connect into this now and then tell it how to connect to my Wi-Fi. I'll disconnect this, we'll wire it up with a big fat ground connection as well. Apologies for the sound quality earlier on. I had the camera set to a wrong recording mode with the zoom microphone, which isn't really good if you're behind the microphone at the time. Anyway, I thought I'd show you the web interface of this unit just so you can see what it's got on there. This is the basic landing page when you log into it, and you can see it's actually charging right now. It's pulling just over 14 amps, and you can see on the setup, which is on the right at the moment, you can see the maximum current is 24 amps. That's what I've actually set it to. I can also put it into advanced display mode, which pushes that over on the left, and you can see the extra safety features which are enabled at the moment. The minimum and maximum current levels, you can see you can dial this right down to 6 amps or all the way up to 32 amps. The sensor scale is used for calibrating the current metering, although if you change the sensor scale, I've noticed it doesn't seem to change it actually on this page. Now whether it would change after a reboot, I don't know. But I've changed that whilst trying to calibrate it, although I did settle back at 220 anyway. But whatever I set it to, it still showed on here as 220. So just a little thing of note there. Then you've got the hardware version and the firmware versions. I've slightly upgraded the firmware, first thing I did when I powered it up. That's your basic monitoring screen. And there are a number of tabs at the top. The second tab along is the system page, where you can see how you can set the wireless up. And if you start it up and it can't see the wireless for whatever reason, it will revert to broadcasting its OpenEVSE default one until it actually spots the old wireless network again, in which case it'll turn that back off and just start communicating with it directly again. So you can see this is where you can upgrade the Wi-Fi firmware, and you can set an admin password if you want to have an admin login on there. And this gives you the opportunity to change the Wi-Fi network as well. There's a developer mode. Now if I turn developer mode on, you can see it puts that Rappy icon up in the top as an additional tab. We'll take a look at that shortly, but not before looking at the services tab. And this is where you can integrate it with other systems such as Emoncms, and you can see I have set it up with Emoncms, so I'll show you that in a second. There's MQTT, which is enabled but not actually doing anything at the moment because I haven't got anything to communicate with that. I may be able to set up Domotix to work with that, because I do have a Domotix server, but at the moment I've got working with the Emoncms anyway, so it probably doesn't matter. There's OhmConnect, which I've not actually looked at OhmConnect at all, so you'll have to look that up yourself. So finally, let's look at the Rappy option, and this gives you access to some application programming interface commands, and you can see there's a whole list of commands here, some of which are for getting information. For example, if I do $GU, I can get the energy usage out of it, and it's read it back there. So these can be captured by external software that can just query these things and just haul the information back out. And there's a bunch of set commands as well. You use the Rappy commands for changing the charger settings, for example. If you want to adjust the current output or the calibration for the meter, those are all set commands which are here. One thing I noticed isn't here, which I'd like to be on here, there's no option for locking the front panel of the unit itself. While you can change settings on here, you can also change the settings on the front panel. There's no means of actually locking that button down to just being a sleep or wake button. So, you know, the press and hold on there where you can actually go into the settings. As far as I can see, on this version, you can't actually lock that out. So someone could push the button and start meddling with the charger if they wanted to. It'd be a nice one to have in a future release. Whether they will, who knows. Anyway, I did mention the Emoncms. We can take a look at the Emoncms now, and you can see this has a number of feeds which we'll pick up from the OpenEVSE. It's constantly sort of feeding back data into this, and you can also do some you can generate inputs from there as well. You can see they've got this watt-hour accumulator, which is actually a kilowatt-hour accumulator, which I've got set up. Meddled with this, hence it having two multipliers to get the kilowatt-hour reading from the watt-hour reading. And that's why the name is wrong, but I've already got it set now and I don't want to lose the data I've already generated on there. And this can then be used for graphing. So you can see that we've got this usage graph here showing the, well, this is actually showing the past week's worth of usage, and you can see the previous week and the previous week before that are also overlaid on top of this as well. This is a complete custom dashboard here. You can actually just drag and drop whatever graphs you want in whatever position you want, and you can make this thing public so people can all view it and stuff. And there are also other apps you can add as well, like this time of use app, and this will take that graphing information and will show. You can see I've got the day and night rate, so you can see, you can work out how much energy you've used. It's also got an option you can choose to show the cost if you fed in the information about the cost, the pence per kilowatt hour. There are some slight bugs I've found here. I don't know whether it's to do with the OpenEVSE itself or the app or a bit of both. What I had to do is set the end time of the night rate electricity tariff to be later than the shut-off timer I've got set in my OpenEVSE, because it seems to only measure it from the time it completely stops charge. That's not when the car is fully charged, but it's pretty much, I think, when the charger has decided, right, that's it, the car has finished demanding power from me now and I will stop. So that could be when you take the cable out, for example. So it's there's that. So I had to adjust those then, otherwise because I've got the charger set to go to sleep at 10 o'clock, it would show the entire thing at the 10 a.m. tariff, which is normal day tariff. Also, there are some errors you can see here, where I know the 24th was an all day, was a daytime charge, because the car was away that weekend. So when I brought it back, I put it in on charge. But the following two, you can see it's got these as day rate charges, but if you look at the graph, they're actually night rate charges. So I don't know what's caused that. So it's not exact, but it gives you an idea of what you can do. And obviously you've got the raw data there, so you could, instead of doing what I'm doing and criticising an app which someone spent a lot of time doing, you could try and pull your finger out and create your own app and realise just how difficult it is and gain some new respect. You might be able to better handle the watt hour data over time and split these, so even if you've got a charge which straddles a day and night tariff, you could correctly split the day and the night tariff by pulling that data out. But maybe I'm nitpicking here anyway. I did try another time of use app which I found was a lot flakier than this one. It looked similar, but it didn't seem to work well at all. So I settled on this one instead, which seems to do the trick nicely, apart from, like I said, those little bugs. Anyway, so that's the OpenEVSE. Interesting little box, not without its flaws. I mean, the issues I've had with it, my little bugbears about it are, it's not easy to fit an additional earth cable because of the proximity of the two cable glands to each other. If they were a bit further apart, it would have been easier to get that gland in. As it was a very tight squeeze to get that extra gland in, and I had to cut the metal backplate as well. Also, the lack of a locking facility for that front panel button, and the double-sided tape to hold the Wi-Fi module in place. But I'm sure there are other chargers where if you pop the lid off, you'll realise why some of them have got tamper-proof screws or they're welded shut. So there you go. Hope someone finds this useful. If you want to take a look at other chargers, Mike's Electric Stuff has taken a sample of some of the chargers you can buy from online. I think he bought some from AliExpress. So I'll put a link in the video description. So go take a look at that. And he's got one of these on his wall as well. So I'm not alone in buying one of these OpenEVSEs anyway. Thank you very much for watching. I'll see you soon.